now that we have a way to measure the duration of a zero investment portfolio, we can now move on to asset liability management, right? So this is a very important concept for financial institutions. For example, commercial banks that have a mismatch between their assets and liabilities. So for example, banks typically borrow short term, either through deposits or money market interbank borrowing, okay? So very short maturities, up to 1 year or so. And then their assets are potentially very long. For example, you can think of fixed rate mortgages that can last for 30 or 40 years, okay? So they have high duration on the assets, low duration on the liabilities. So this creates a mismatch between these two sides of the balance sheet. And in this example, for example, if interest rates go up by a percentage point, for example, you will see a very sharp drop in the equity value due to this mismatch between assets and liabilities. Okay, so how do we manage this? So the idea is the following. We want to minimize the exposure of the bank's equity to this interest rate risk, right? So how do we do that? First, we have to measure it, okay? We have to say exactly how much that risk is, meaning we have to compute the dollar duration of the equity, okay? So we're going to look at the balance sheet together, and the dollar duration of one side of the balance sheet, the assets, has to equal to the dollar duration of the other side, which is equity plus liabilities. So that's this first equation here, and that by difference, I can find out that the dollar duration of equity is the difference between the dollar duration of the assets and the liabilities. So that gives me the measure of the risk. And then I'm going to take actions to manage that risk. So I can adjust the composition of the assets and the liabilities to drive down the dollar duration of equity, the exposure, the sensitivity of the equity to interest rates. In the limit, I could make that sensitivity become zero, okay? And in this case, there would be no interest rate risk, right? So let's look at this example here. Again, this is from the book that we are following. This is a balance sheet of a commercial bank. This is a very stylized example, very simple, but it captures very well this trade-off, this risk that we are describing here. Okay, so on the assets we have again a very simple balance sheet, just 4 lines. We have cash, short-term loans, medium-term loans, long-term loans. Okay, and then on the other side, on the liabilities, again very simply, we just have 4 lines: deposits, short-term debt, medium-term debt, long-term debt. Okay, so we have already aggregated all the different items that might be inside these lines here, and we have already computed the aggregated market value and the duration of each of these items. Okay. All right. So first step again, let's compute the risk. Let's compute the dollar duration of equity. Okay. So we have seen the formulas before in the previous video, and if you go up here in the handouts, you will find that we have this formula here, which is very convenient, which is that the dollar duration is equal to the market value, so one of these numbers, times the duration that is computed in the traditional way, right? So if we go through the balance sheet, let me change here to here. Okay, so if we now go through the balance sheet, starting on the assets, line by line, by cash, we had this amount of market value, $100 million. The duration was 0. So the dollar duration is the product of the two things. For short-term loans, the market value was 300. The simple duration was 0.8. So the dollar duration would be 240, and so on. We do these multiplications and then add up these 4 lines, and that gives me the dollar duration of the assets. The same way for the liabilities, do the product, then add up everything, and you get the dollar duration of the liabilities. So by difference, assets minus liabilities gives me the dollar duration of equity. Okay, doing that, I get the dollar duration for equity of 14,740. Again, in weird units, recall that these market values are in millions of dollars. The simple durations are in units of years. So I get, again, this weird thing of money times time, or millions of dollars times years. Okay, I don't know what this means. So let's do a scenario. Okay, so here, contrary to what we have done before, I'm actually doing a change in interest rates which is significant. This is not 1 basis point as before. This is actually 1 full percent. Okay, 100 basis points. Now this is a large change. It's not something that happens overnight, right? But it is a scenario that may happen over the course of a few weeks or a few months. In fact, the banking supervision asks banks to report what will happen to their balance sheets for interest rate changes like this, and even higher, like 2%, for example. Okay, so 1%, it's not something that happens every day, but it is something that happens, and that banks have to be prepared to withstand these changes. Okay, so 1%. So what is the change in equity? The formula is exactly the same as we saw in that repo exercise, which comes from the definition of dollar duration. So the change in value, which now it's the value of equity, is approximately equal to the dollar duration of that same equity times the change in interest rates. Dollar duration of equity, change in interest rates. So now we will do the product of these two things, and we get, again, the units cancel, the year units cancel. So we get just dollars, which we know what it means, right? So if interest rates go up by 1%, the value of the equity goes down by $147 million. Okay. Is this significant? Well, let's go back to the balance sheet that we have here in the handouts. So what we're saying is that if interest rates go up by 1%, the value of equity goes down by roughly $150 million. Okay, so comparing that to the $600 million that equity is worth right now, it's roughly 1/4, right? 25%. So if interest rates go up by 1%, shareholders lose 25%. So it's very significant. It's a very large chunk of their total value, right? So that's why asset liability management is so important in banks, because they are very risky. They're very sensitive to interest rates, to changes in interest rates. So what can the bank management do? So at this point, what they could do is they could try to manage their balance sheet in the sense of reducing this mismatch between assets and liabilities. So if they have very long assets, they could try to reduce the duration of those assets. So what does that mean in practice? So in this example I was giving, if we have, if the bank is giving loans for 30 years, for example, the bank might say, we're not going to give you a loan for the client. We're not going to give you a loan for 30 years. We're only going to give you a loan for 10 years. Okay. Obviously, the client might go elsewhere, so the bank might lose customers. Okay. On the other side, let's think of the liabilities. So the liabilities, the problem here is that the liabilities are too short. So the bank would like to have longer liabilities. So the bank might try to borrow for longer maturities. It is now borrowing in the interbank market for 1 year, and it would like to borrow for 10 years, for example. The problem again is that there may not be investors willing to lend to this bank for such a long period at reasonable prices, at reasonable interest rates. So again, market conditions may not allow the bank management to do what they would like to do. All right. So in practice, the bank cannot do much on its own. So what banks actually do is that they use derivatives to manage this type of risk. So when we get later on to the chapters on derivatives, in particular to interest rate swaps, we will see how we can use interest rate swaps to manage exactly this risk, and we will come back to this example. All right.